We have one more speaker before lunch, representative of RoCal, where our plant tour will be 2 weeks from today. Scott Chapman is here. He's a graduate of Cal State University in Los Angeles. He worked for a number of years with Stimsonite, reflective sheeting manufacturer, and with Hall Signs in Bloomington, Indiana for a while, and is now with RoCal. And he's going to talk to us about their sign manufacturing operation. And after that, we'll have a brief presentation about the plant tour this afternoon. Scott, are you ready?
Okay, Scott.
Yeah, that's good. Thanks, Matt. Well, I have good news and I have bad news. The good news is even though I worked for Sablite for many years, you're not going to hear yet a third perspective or the Japanese perspective on reflective sheeting. But the bad news is you still got to listen to me for the next half an hour before we have lunch. As Chuck said, I work for RoCal. If many of you have not heard of RoCal, don't worry, you're in good company. A lot of people have not heard of our company. RoCal's been in the sign manufacturing business for well over 30 years, but we are most well known in the contractor community. Most of our typical customers are contractors doing state highway work. If you've driven on any interstate highway across the country, you've seen the signs that we produce. We produce everything from East Coast to West Coast, whether it be panel signs, like some of the extrusions I'll show you a little later, or flat sheet sign. But that is our traditional customer base. We have some tremendous in-house engineering capabilities. In fact, the diversity of materials that we work with led us to be selected by the Olympic Committee and Georgia DOT a few years back to custom fabricate all the guide signs to the different Olympic venues. There was a very big project done in very short order. Somewhere in the neighborhood of 45 to 50,000 square feet of custom signs were produced at great expense and used for about a period of 1 to 2 weeks before they all disappeared. But it was a very nice project and a fun one that we were involved with. The fact that RoCal does a lot of work for state departments across the country means that we are exposed to a tremendous amount of different materials and a tremendous amount of different material specifications. I think you've all heard the joke that military intelligence is an oxymoron. Well, I think so is the Manual on Uniform Traffic Control Devices. As you go from one state to the next, there is very little that is uniform about each state's manual. Most of those changes or the differences are subtle, but from a fabricator standpoint, they're very, very, very critical. Most states, though, do have good reasons for making some of the modifications they do. And as a fabricator, we're most happy to give the customer basically whatever he wants. But a lot of those changes have to do with some of the material formulations, a lot of the different hardware that's used. Matt just mentioned problems that you can get into with drive rivets not being the correct type and size. Well, the same thing is true with bolts. There's inexpensive bolts, there's cheap bolts, and then there's very good high-strength bolts. And that plays a big part in the longevity of a sign installation. A few years back, I was asked by the Institute of Transportation Engineers to write a chapter for their traffic sign handbook on sign fabrication. So after many sleepless nights and gallons of coffee, I prepared about an 80 or 90-page manuscript for publication, and they came back and said, "Well, Scott, just a little bit too detailed. Can you cut this down a little bit?" So we chopped and cut that from 90 pages down to 40 pages. And they still came back and said, "Well, that's good. It's all very interesting, but it's much too long. Drop it down to 20 pages." So everything you ever wanted to know about sign fabrication got condensed into 20 pages, and today we're going to do it in 30 minutes, so you're going to have to listen up. How many, before I get into this, how many of you have your own sign shops or involved on a day-to-day basis with sign fabrication? Okay, looks like it's about half of us. Sign fabrication capabilities among government agencies really runs the full spectrum. From agencies that buy flat sheet aluminum, have their own metal working equipment, they share it to size, they cut the radius corners, put in their hole locations. But if you're in the more common group, you're probably purchasing aluminum sign blanks that have already been cut and treated. Perhaps you're buying pre-screened faces and just applying that to your aluminum. Or you may actually even be purchasing sheeted blanks, and maybe you're just doing street name sign fabrication. So there's a whole range of levels that cities and counties are involved with sign fabrication. Jim Roth talked this morning a lot about the different types of substrates that are involved, and I've brought samples with me up here. And even though you're not producing signs for a state highway system, some of these materials still have excellent application for some of the types of signs that you may get involved with. Of course, the most common is just the 080 flat sheet aluminum, and I think that's something that everybody is very, very familiar with. But as you get into street name signs and some of your longer signs where you're looking for something that's a little more rigid, a extruded sheet, which is kind of called a dog bone extrusion because of the shape of the profile, is used quite commonly for street name signs. These can be mounted in cast aluminum brackets on top of posts. Or in the case of the city of New York, there's a extruded aluminum bracket that fits on the end, and we just drop in holes, and the bolts go through the holes, through the bracket, and the bracket in turn is banded to a light post. The extrusions, of course, are a little more expensive than the flat sheet aluminum, but of course there's more aluminum in it, and that's what makes it more expensive. The shape of the extrusion gives it more strength, gives it more resistance to flapping in the wind. These are typically available in 6-inch widths, 6 3/4-inch widths, 9-inch widths. Occasionally we've seen a 12-inch width used, but that's pretty rare. Most common is a 6 3/4 or a 9-inch width. In terms of length, they can be produced in lengths up to 144 inches, but that really exceeds the practical usage for anything that can be a street name sign. Typically, these fall within the 24 to 48-inch length. Another type of substrate, Jim talked about this morning, are extruded panels. The piece that he had was just a 12-inch wide. Typically what is done is various widths of this panel are bolted together using stitch bolts. And in this manner you're able to fabricate a sign as high as you need it to be. Typically these are used on the interstate system as guide signs. The panels are held together in the back by stitch bolts. Something that's unique about the profile of this fabrication is that at each end it's slightly recessed, so that when the reflective sheeting is applied to the face, it's actually bent over and actually sandwiched between the two different panels as they're connected. And that's by design. It protects the materials from delaminating here in the joints. These panels then are connected to signposts in a number of different ways, and it really depends on what type of a signpost you're fixing it to. These aluminum sign clips are used very commonly to attach the panel to either a U-channel post or an I-beam, and they have a special bolt with a square head that fits directly in the channel, and as you tighten the bolt, it pulls everything snug. You could also use a very similar bolt to bolt it right through to a square post. Something that I really like about this, and again, chalk this up to a quirk from a sign fabricator, is that you have a blind fastening system. So from the front of your sign, you don't have any bolt heads. You don't have anything that detracts from the message of the sign. All of your fasteners are here on the back of the sign. Now, I guess if there's a drawback to this system is that you have a panel that's 12 inches wide. So every 12 inches wide, you have a seam here where the reflective sheeting is. And that can be noticeable during the daytime, but it's not a real big issue. But nevertheless, you do have that seam across there. When you're putting copy across the top, if you're putting direct applied copy, you need to cut that where the seam is so that the reflective sheeting is very well bonded to the material underneath. Similar to the extruded panels is a product called extrude sheet. And at first glimpse, it looks very similar in profile, but it's really quite different. Extrude sheet is fabricated using flat sheet aluminum with stiffeners that are spot welded. And again, this varies by state. Sometimes the spot welds are 4 inches apart, sometimes they're 3 inches apart, sometimes they're 6 inches apart. But the spot welding creates a very, very strong union between the stiffener and the face of the sign. And then again, stiffeners can be put anywhere along this back sheet, depending again what the requirements are for the strength of the panel. Jim, correct me if I'm wrong, I think the maximum width panel on extrude sheet in Ohio is 36 inches?
We go to 48.
Okay. Yeah, in the fabrication process, yes, we can go up to 48-inch wide also. Again, an advantage here over the extruded panel is now every 12 inches you don't have a seam of reflective material there. But you've got the same ease of attachment, uses the same hardware on the back, whether it be the sign clips or whether it be special bolts for locking the sign bolt directly to the post. A lot of communities take a lot of pride in custom designing the welcome to City of Frankfurt signs as an example. This is an excellent material to use because those signs tend to be large. Many of you go with the 96 by 48. So by using this product, we're able to spot weld stiffeners on the back, so you've got a good strong structure, and you're able to have a nice clean face on the front, free of any fasteners, just to detract from the aesthetics of the sign. Again, that can be custom fabricated in any width, whether you want 18-inch, 24-inch, 30, 36. Really, up to about 48 inches is the maximum limit. Your other flat sheet signage can also be strengthened. There's a variety of different types of stiffeners, and again, these come into play with your larger signs where you want some strength behind it. This is just a fabricated extrusion. It can be cut to the length of your sign. Again, it can be bolted to the back of the sign. It can be spot welded. It can be attached with a high-strength foam back tape with excellent results. And again, it just allows you to have a more rigid sign face, and now you can take advantage also of a blind fastener on the back so that you don't have bolt holes fitted into the front. Some of the other type of substrates that we get into are plastics and fiberglass, and like everything else, they all have their advantages. They have their disadvantages. If you work with plastics, I can only caution you just to be very careful because every plastic is different, and they all have an impact on how durable your sign is going to be. Many types of plastics outgas, and when they outgas, this gas comes up and gets trapped between the substrate and the reflective sheeting, so you wind up with a bunch of bubbles on your sign. And that, of course, will shorten the life of your sign and in many cases, void the reflective sheeting's manufacturer's warranty. Let's talk a little bit now about methods to apply the message to the front of your sign face. And here with the computer technology, this is probably one area where, as a fabricator, we're seeing a tremendous amount of change. Traditionally, messages were applied either by using direct copy. By direct copy, I'm talking about reflective sheeting. It has been either die or saw cut to shape, whether it be letters, whether it be symbols. And this copy is simply applied to the top of the reflective sheeting. The other traditional method has always been screen printing, using either in the case of colored, transparent ink, or black opaque ink. Well, they've all got advantages. Some involve very costly setups, so if you're going to do a large-scale production run, screen printing has traditionally been the lowest cost method of producing the sign. Short-run, one-of-a-kind signs, traditionally die-cut letters have worked well. Many of you do use die-cut letters if you fabricate street name signs by yourself or in your own shop. But one strong word of caution, traditionally people tend to take some of their scrap material, some of their end cuts, throw that into a bin, and as they get time, they die-cut letters. And some of that material tends to get kind of old without you really knowing it. And it starts to go well beyond the intended shelf life of the product. In addition, you wind up with reflective sheeting from several different manufactured lots of material. And within each manufactured lot of sheeting, there's a slight color difference. And some of these color differences are more apparent at night under reflected light than under daylight. So you may pull a bunch of white letters from a bin, and in your shop it looks nice and pretty, and you put up on a sign, and now you've got 5 or 6 different shades of white up on your sign. You also may have 5 or 6 different lives of material up on your sign, so that over time as that sign ages, some of your letters start to darken earlier than the others. So again, rotate your sheeting stock, whether it be your scrap that you're making cutouts or whether it be your roll good. Make sure you rotate that well and keep it fresh. You had a discussion this morning from 2 different reflective sheeting manufacturers. Rocal has worked with basically every brand of reflective sheeting that's out there and is available. Of course, each different sheeting has its slightly different handling characteristics. The biggest thing I could advise you to do is to be well aware of the recommended procedures as it relates to each particular manufacturer. It would be impossible for me to take a position and tell you one brand is better than another for this reason or that reason. I can tell you, and I can give anybody total assurance on this, that every brand of reflective sheeting out on the market today that's sold for use for highway signs is very, very well backed from the standpoint of the strength of the company behind it with their warranties, from the strength of their technical service. And they meet federal specifications. Some brands or manufacturers may be in the stages of getting approval, so they may not be state approved. But as a local agency, that's your call to make on whether you use the material. But I guess I wouldn't worry from the standpoint of a company not standing behind your material as letting that get in your way of using the material. We've had excellent results from a technical standpoint and from a warranty standpoint with every major manufacturer of reflective sheeting. So I digressed a little bit. Let's get back to the method of applying your message to your sign. We talked about the traditional methods being die cut, saw cut, or silkscreen printing. Newer on the market today are the transparent cuttable films. And again, these are designed to be cut primarily with electronic cutting equipment such as Gerber. You can cut out the reverse message and apply that directly over your reflective sheeting. Again, this is an excellent fabrication method for short-run signs where you don't have the high setup cost and the long setup times that you do on screen printing. There's a number of different manufacturers that produce the transparent material. There are many different types of materials, but again, it's a very good method to produce short-run signs. Again, just become familiar with each manufacturer's type of material and be sure that it's compatible with the reflective sheeting that you're placing it on. Generally speaking, the transparent films that you can place over your sheeting will have the same life and carry the same guarantee as the sheeting that it's placed upon. In applying the message to your sign, the biggest thing you've got to watch for is cleanliness and cleanliness of the surface of the sign. Reflective sheeting will only stick as good as the surface that it's being applied to. If you purchase fabricated aluminum sign blanks from any of the major sign manufacturers, you generally get a sign blank that's clean. It's been through a cleaning process where all the oil is degreased and removed, and there's a chromate coating placed on the blank. That chromate coating does two things. Number one, it helps prevent the aluminum from oxidizing, developing white rust, and it also prepares the surface of the aluminum for the application of sheeting or paint, whatever type of material you're placing on it. A drawback if you're having your sign blanks reclaimed, that is where you're sending it out and having it sanded, is that sanding removes the chromate conversion coating on the aluminum. Now that's not a problem if one of two things happen. Number one, if the person sanding it off runs it through a tank and reapplies the chromate conversion coating, or number two, you apply the reflective sheeting to the surface fairly soon after it's been sanded, because now you're able to seal the surface of the aluminum and prevent any oxidation across the surface that may inhibit the sheeting sticking to it at a later date. Again, keep things really clean. Before you apply the reflective sheeting to the aluminum, make sure that you run a tack cloth across it. Sometimes a rag soaked in a solvent solution is very good for removing any type of oils. Even the oils from your finger can inhibit adhesion from reflective sheeting. So make sure your surface is very clean. That's true not only before you apply the sheeting to the aluminum, but that's true before you apply your die cuts or before you silk screen across the top of the sheeting. Ensure that it's very, very clean. Again, for printing, every manufacturer has their own recommendations. Key is to make sure it's clean before you print it and keep your material in a very clean, dust-free environment. While that ink is still wet, it will attract dust particles, and there's nothing worse than a stop sign that's an inch thick in dust. That's a little bad. It doesn't usually get that way, but again, keep your signs in an area where as the ink dries and cures, it won't be subject to a lot of dust and other foreign materials blowing across the face. After you've finished fabricating your sign, storage is the next key issue. Storage is also a key issue if you're purchasing finished signs from a fabricator such as Rocal. Generally speaking, treat the surface of your sign like you would the surface of a brand new car or a freshly painted car. Now that doesn't mean that you need to wax the surface or anything. It just means you want to keep it clean, because the same types of dirt particles that will scratch the surface of a car will also scratch the surface of a sign face. Too many times we see customers who will receive a shipment of signs, and they'll take the signs, and the first thing they do is they'll unpack them. They may have a stack of 15 or 20 stop signs, and they'll remove all of the slip sheet that protects the face of the sign from the sign that it's packed next to. They'll throw the slip sheets in the trash can, and they'll put their stack of 15 or 20 signs up on the shelf and say they're ready to go. Well, what'll happen as heat and humidity affects these signs as they're in storage, they will stick together. And the fact that they stick together has nothing to do with the ink being wet when the signs were packed. Not a thing to do with it. Just the fact that that material will stick together if it's placed together surface to surface. The slip sheet is in there not only to protect the sign as it's being shipped, but also as it's in storage. So don't remove those slip sheets. Also, as your maintenance crews are transporting signs from storage out to the job site, ensure that those slip sheets are still between the sign faces. It's best to take some packing tape or masking tape and tape together the stack of signs so that when they're in the back of the truck, they don't vibrate or they don't rub together, because that'll also scratch the surface of your signs. So the key is keep them clean, keep them protected by slip sheet. It's best also that when your signs are in storage that you keep them in a dry area. Again, because as they're stacked together with that slip sheet, if it gets wet, the slip sheet can get stuck to the surface of the sign as well. If you've got signs that have been in storage for any amount of time, and granted you've kept the slip sheet in and you pull the slip sheet off, sometimes you'll notice kind of a haze or a marring across the surface of your brand new sign. And basically it's a mark, it's an impression from the slip sheet. But it's not anything to be concerned about. Typically that dulling or that slight mark, it's almost like if you can imagine taking wax paper and sticking it onto a pan, you get a little bit of transfer of the wax to your pan. The same thing happens with slip sheet when it's against the face of the sign for any length of time. But once you've taken that out, you hang the sign outside in a matter of a few days or weeks. The natural weathering process will tend to eliminate that slight dulling of the surface, so it's not anything that you need to be concerned or worried about. When your signs are in storage, again, it's best if you keep them stored vertically so that you don't have the weight of the material dulling the surface of the sign or possibly in very severe cases damaging the cells of the reflective sheeting itself. And that's a bigger issue with the high performance materials than it is with the engineer grade materials. Okay, that's a very quickie on sign fabrication. You'll see it's much easier to understand when you see the process being done. Like Chuck said, in 2 weeks we'll be giving a tour of the plant. If you're not signed up for the program in 2 weeks, RoCal is more than happy to offer tours of the facility anytime you'd like to come on down. If 2 weeks from today doesn't work for you, if you give me your card or give me a call at my phone number on the handout material, I'd be more than happy to arrange a tour of the plant for you at any time. Are there any questions? Yes. They're very, very similar. I don't. Boy, I don't have that information off the top of my head. They're very similar. It's very close. I believe the extruded panel is slightly heavier than the extruded sheet. But even on extruded panel, there's a lightweight extrusion and there's a heavyweight extrusion. They both have different panel weights. Any other questions? All right, well, thank you.
A couple of more things to take care of before we get through. Don't forget your evaluation sheets. We'll now hear from Rick Maurer of Marion Steel. He's a national sales manager for the signpost division. He'll talk to us about the Marion Steel's breakaway design, and he'll also give us instructions on how to get to the plant tour. I think that's right. After he is through, keep your seats and we will pass out the certificates before lunch. And then just leave your evaluation sheets at the place where you're sitting. Rick?
Thank you, Chuck. We're going to do today, basically, it's a couple different things. One is we're going to invite you out to the mill after lunch here to check out and see how we actually make our posts. We'll also have a rather fun thing. We're going to be actually running into signposts for you and show you some of our new products and actually how they work out in the field, and we're going to actually tag them out in the field so you'll have a good idea of what's going on. What I came prepared to do today was to present a TRB paper based on our new product, which is the Marion Steel Slip Safe. It's a slip-based system that we've found works rather well, and we're extremely excited about it. It really can change things we feel out there in the industry. One of them is reusability on both stubs and top posts, and hopefully some of your sign panels as well, if they can handle the hit. What I'd like to do is going to run through a brief slide presentation on the slip base itself, where it came from. I'm going to hit up or we're going to queue up right now a series of crash tests on the monitor so you can get a chance to view a real live crash test or a tape crash test of what the feds actually look for when they hit something out in the field. Let's see if we can get the slide picture on there. Okay, Mary Steel slip safe system is basically a slip base casting. Here's a picture of our single that you're going to bolt into a series of signposts. You have a stub post, you're going to have a top post, bolt it all up. When a car hits it, the slip base is going to activate, come right apart. If I put the one that rips in there, twist, we'll cheat. Slip base is going to activate, and you're going to wind up with a stub in the ground, and you're going to wind up with a top post somewhere. Hopefully it's going to be rather close, and with any luck, you're going to be able to pick this top post back up, put it right back on with a new keeper plate, which is this little doodad right here, and you'll be right back in business and be able to have your sign back up and working. Give you a little bit here more in terms of the design of the system. This is a back-to-back system, which we'll be showing you here in a second. Back-to-back is designed for much more sign area. What you do is you take two sign posts, and you guys are, I'm sure, aware of the piggybacks that are out there. You just piggyback up the posts, slip it into your slip-based system, and boom, now you've got a federally approved breakaway. In terms of sign areas, this system is going to be able to hold up over 100 square feet of sign. That little teeny slip base with just a couple pieces of 4-pound posts. It's an amazing little system, and the reusability of it is just terrific. A little bit more here in terms of, there's the single, and that's how the single's bolted up. One of the revolutionary advantages of this system, as opposed to what we've done in the past, or an easier wreck or something along this lines, this system here relies on the performance of the hardware to actually have to break or yield. What we're doing with a slip base is you eliminate any of the hardware involvement in passing a crash test. Here's a triple posted slip base that we've bolted up. It's back to back. There's our test vehicle that we used in the impacts. It's an 1,800-pound vehicle. The first series of tests that we had to do, you have to put them all in sand. So you use a stub post with an anchor plate in the sand in order to be able to hold the soil. The car is going to come in at 20 miles an hour on your first one in sand. The car does the same thing in hard soil. You change your soil types out. And then you have to do a fast hit. The fast hit's the one we're going to try to show you here in a couple minutes. And you need to do that at 60 miles an hour. Here's a 20-mile-an-hour impact. It's our first test, sand. Your stub posts, you can see them underneath the vehicle. They're not moving at all. The post is actually separated. Your castings, or the bolts, you can kind of see here going a little bit of front. Post comes right on out and doesn't really injure the car at all. It gets slapped on the roof. You can see here, the little sign panel is actually going to come down and whack the roof of the vehicle. The car then actually travels through the area and comes to a nice pleasant rest. Here is the second one in hard soil, another slow impact. Again, it's extremely predictable. The system works and reacts the same each time. We were within probably a quarter inch here on the roof from the first impact. It's the same test vehicle. As you can see, there's really no bumper damage on the thing at all. The occupant He's not really forward much in his seatbelt at all. There's really no energy that's being given to that guy that's going to force him to get thrown through a windshield or cause any damages to the people in the vehicle. So we've come up with a very, very safe system. There it is there. Another shot of it. This is what you're left with in the ground. Your stubs, totally reusable. They don't move. Your hardware, if you can pick up the bolts, you can reuse them. Believe it or not, in this test, in this series of tests in order to get our FHWA approval, we used the same top posts, we used the same stub posts, we used the same nuts and bolts. The only thing we had to change out was the keeper plate. As a rule of thumb, when you run these crash tests, you trash the vehicle a good number of times. We didn't experience any of that. We were able to reuse the same vehicle the whole time. Oops. Our first crash test that we did, we came in at 1.5 meters per second. Second one, 1.4, and the last one, at 60 miles an hour, we achieved 1.6 meters per second. You're allowed 5 meters per second in order to pass the crash test. There are a couple criteria you need to have. One is you can't put anything through the crash test dummy and kill them, theoretically. You can't encroach on the vehicle and totally crush the vehicle or have any intrusions, anything coming in. You can't have your stub post or anything up left out of the ground anything more than 4 inches after the impact. And you can't cause any frag or stuff to fly away from the vehicle and cause hazards to other traffic. And in terms of your change in velocity, it's really what everybody looks for because it's the hardest thing to get, is how much are you going to throw that guy in the car after the impact? Are you going to stick him right through the windshield and have a problem? Or is he just going to be snugly retained by his seatbelt? Anything around a 5 is bad and would fail you automatically. We're on the very, very low end of this scale. Majority of our products and other products out there in the market like this just pass the crash test by a whisker. I mean, they're like 4.8, 4.9. They're just barely passing. What happens in all that is you have a lot of energy transferred. Kind of think about it. You got a guy in a car, he's going to hit a post. He has to break something. He's got to use energy in order to break it. And when you do that, you wind up having that energy transferred from the vehicle, which is going down the road, into the post itself. Because of our steel, it's 80,000 psi billet steel. It's far different than other pieces of U-channel. This stuff is only 60,000 psi. It's about 25% stronger. It is able to take that energy, transmit it up and down the system, activate the slip-based bolts, and cause really no damage to the top posts, no damage to the stub posts, and very little impact change on or change in velocity on the driver. We also did some pendulum tests to check out single supports and see how they were going to work and how they were going to function. We also did pendulum tests in order to shorten up your stub posts. A lot of guys don't like to have to drive the stub post all the way down on the ground. In the soft soil, we were using 5-foot stub posts. I believe the square tube guys use a 4-foot stub post or 48-inch anchor. We can use a 42-inch anchor, and in sandy soils, we've actually gotten approval for a 30-inch piece of post with a 28-inch embedment. A lot of guys wouldn't put that up. They'd probably want to concrete it in order to give it a little more bearing area. But if you had a situation where you had underground utilities or something like that at 36 inches, you could use this system without any problem. Here's another, that was a good shot. Here's a, back up there. Here's a good shot of the pendulum impacting the single post. Okay. Basically, in the end, what we found is that The slip-based system functions and meets all FHWA criteria, that you can use it for 3 posts in any type of soil condition, 3 posts on one sign panel in any type of soil condition. You don't have to worry about your stub lengths. You can use the same type of posts in terms of that you have out there in the field right now. You've got usually 42-inch anchors. You can take those same rip-back posts and match them right up with the slip-based systems. Our systems are very inexpensive in terms of this market. We're offering this system for about $15. It's a really nice deal in terms of offering reusability at a very low cost. We've also got other systems that we're going to show you out at the mill, which you folks have seen on the contract and probably some of you are using today. We've got the lap splice system. We also have a Minuteman system, which we're pretty much going to be discontinuing now that this has come along and moving into. And then we've got just a straight piece of U-channel post. Today we're going to hit 3 different ones for you. Right now what I'd like to show you is the tape on the 60-mile-an-hour impact. Okay, there we go. Fast forward a little bit. Basically, you've got the same vehicle. Sign. You have to stitch bolt up the back-to-back system about every 18 inches. This looks like about 20-mile-an-hour impact. So that's the second day. You can see this from another angle. Car hits the post, hardware is thrown out, post comes down, that's the roof. Nose on it. Fast forward here till we get to the 60-mile-an-hour impact. You can see right here, the picture before, frame before, you can see the system in the ground, the soil plate with the soil not really moved at all, and the post is totally able to be reused. We'll shove it down the roof. Fast forward, same vehicle, same sign panel. And the sign panel, I believe, was either 5/8 or 3/4 inch plywood, and it was able to be reused as well. That's your full vehicle. She comes in right now, 60 miles an hour, passes right through. All of your posts, all of your uprights are totally reusable again. You can watch them actually flex a little bit when the thing gets hit here. This flexes just a little bit, rotates right around the vehicle. Almost stands right back up for you. Wouldn't that be nice, huh? We're going to give us a slow motion shot here in a second. This isn't slow-mo. Right around. There you go. Cadillac would be fun. So that's pretty much the system that we've got right here. We're going to go over a lot more over at the mill. We've got the mill tour. We've got the crash test that we'll do. What we're going to hit today is we're going to hit shorter stubs. We're going to hit it with a pickup, and probably somewhere between 15 and 20 miles an hour. We'll hit a lap splice. We'll hit a single slip base and a double slip base. That's pretty much it for my presentation. Are there any questions out there right now? Shoot.
What happens if you get it sideways?
It's 360 degree breakaway. We put a slot in here, so you can hit this thing from any direction, and you should have the same results. Some of those pendulum tests you saw were actually showing the 45 degree impact on the 45 degree and 90 degree impact of the sign panel itself. So it's the 360 degree breakaway. Yes, sir.
How does it behave in the freeze thaw accident?
Excuse me?
In the winter time, with the freeze thaw going on in the northeast Ohio area,
Right.
how will it behave?
I don't think it's going to be any different in terms of the activation of your slip base. As long as this is impacted from any direction, pretty much at the bumper height, this slip base is going to activate. It takes very, very little energy in terms of activating this. If you have this thing packed around with snow and ice and all the rest of that stuff, it's still going to pop right out of there and activate. Good question. Anything else? Any other questions? I've also got some directions for you how to get out to the mill. It's rather easy. Cruise on out of the parking lot, and as you go out of the parking lot, you're going to have a stop sign. Go through that first stop sign, after you stop, of course, and go up to the second stop sign. It's at Marysville Road. You want to make a left, go down to your first traffic light, make another left, that's Barks Road, and then make your first right. That'll be Cheney Avenue. So it's left, left, right. Okay? And we'll resume over there probably about 1 o'clock.
How far up that street is it?
I'd say it's about a mile, half mile.
You repeat the direction.
Certainly. Straight out of the parking lot, through the first stop sign, left at your second stop sign, approximately, I'd say half mile down the road to your first traffic light, hang a left onto Barks Road, and then it'll be about 100 yards up. You'll make a right onto Cheney Avenue, and we're down Cheney Avenue probably quarter mile.
On the right side?
On the right side is the mill. On the left side is the parking. It's about a minute and a half, 2-minute drive. Depends on how fast you drive. If you're on do the 20-mile-an-hour impact, you're going to take it. Okay, thank you very much.
Thank you, Rick. Talk about slip bases. I saw an accident where an accident happened a few years ago. Involved a slip base that didn't slip. It was on Interstate 75. This was when they first started putting in slip bases. It had a signpost there with a guardrail in front of it. They put in a slip base sign post and didn't remove the guardrail. Car came through, hit the guardrail, ramped up, hit the post high. It didn't slip. It sprung back and the sign flipped over, but the base didn't slip. The 2 people in the car were killed. But that's the fact that they didn't remove the guardrail wouldn't let the slip base work like it was designed to do. Now we got certificates.
Okay, about ready to break for lunch. Lunch is going to be back that way, so you come out, left again down the hall, and straight through into the banquet room. We're going to hand out certificates now, so keep your seat for a moment, please, and then you're welcome to leave your materials here during lunch if you'd like, and then we'll head out to the tour. So we'll start calling these out. Joe Leppel.
Randy Allen. Randy Allen right here. That's Allen.
we're attracting more.
Yeah, it's like go back to work.
I'm going to stop, hopefully right about here. I will stop right about here. But rule of thumb, you never want to hit a post. Post is one,
as a rule of thumb, what you don't need a hinge plate. So why don't we whack the next one and see how it works. So we'll march right along. Okay? What we'll do is we'll hit the single support.
Scratch our truck, didn't you?
Again, what we wound up doing is we left no more than 4 inches sticking out of the ground, which is okay and acceptable. In this case, we would need to replace that stub post, which is not too good. You don't want to have that happen. But, hey, it happens. You never know what's going to happen when you do a demo. Where's your other bolt? My other bolt? In terms of the top of the post right here, it took a little while to get this one in the ground yesterday, and we beat it up pretty good. We obviously beat it up a little bit too good. What we'll do is I'll hit a Minuteman, all right, I'll hit a lap splice here.
That's what I thought. As well as we'd like to here. What was the second one? Was just because of the casting itself was.
The second one, the first one, the casting split. Second time they
was a failure on the actual unit itself.
busted the post. The post gave instead of.
Lap splice system basically takes the post. Basically got a post this. These are grade 9 bolts. These bolts are as hard as the post or harder. The whole idea about our steel is it's fairly brittle. As you can see in that first example, you want to have something brittle so it does yield under the force. If we were more mild or ductile, what you'd actually see is a lot more bending, and that's most likely to allow. So we can use things for hardware. This is your stub post, which you put in the ground.
You gotta drop it first.
Yeah, that's the way it works. We made these things red so you can find them easier. Spin on your hardware. Then you come on in with your top post afterwards. This hardware, because it's threaded, actually acts like a pin. Okay, and this hardware is as hard as our post. It's roughly, I think it's about 185,000 psi. So it's actually more brittle than our posts, and it's actually stronger than our posts. So by being more brittle and by being stronger than our post, we've lost no strength in our connection. And what we've gained is we've gained an area that's going to be more brittle, so we should have a break right here in the hardware. If the stuff is special order, you just can't go up to your hardware store and get it. We've put M180 on the back of the bolts. They're red in color, so it's easy to identify things. If you take a look at this one down here, if you were an inspector or something along those lines, you can quick take a gander. You can see you got red nuts and bolts. If you looked in there, you can see you had a gold bar spacer. You can have an idea the system was correctly installed. When we hit this, what's going to happen is the top post is actually going to start to rotate on this spacer. It's going to break the bolts. It'll break that first bolt, and then it should either break or bend the second bolt and release the top post. Because our posts are really brittle, like you saw there, that one getting cracking, what you'll have happen is in a fast impact, you're going to see the post break at the bumper, okay, with this system. On a slower impact, which I'm going to do today, that shouldn't happen. If I get enough speed and I can get enough energy in there, I will break this top post. Sometimes on this system as well, you'll actually peel the bolts right on through the back of the stub. This system is designed for ease of use and is designed for meeting FHWA breakaway requirements, you know, on a cost-effective basis. Any questions on this system before I hit it and see whether it's going to break? lip on there hangs on this part of the gasket. Socket head gasket. That's what they call it. True term word.
You're going to get a special bolt for this one?
See, or excuse me, the nut. Sorry.
Oh, okay.
Sorry. Right now we've got 2 nuts.
Oh, okay. You're going to get a non-threaded piece.
We're going to get a threaded piece. Got to have special bolt. With a, it's going to look like 2 of these nuts back to back.
Oh, really?
Okay, so you have this little lip in here in order to catch right in there. Follow what I'm saying?
So it's going to be round, right?
Well, one attack says so it catches in there. You turn here.
Okay.
Crank on here, door side up. Right. Okay. These are I want to say it's 250 millimeters, which is 2 inches. So I think it's 2.5 inches.
But it can be applied in so many ways.
That's right. This is for
That was textbook.
Medium sign, and that's the small sign. Yeah. Yeah.
And the posts are all the same. It's just the connection and the type of hardware.
Connection makes the beauty.